Now let's talk about types of airspeed. There's indicated airspeed, or IAS, the airspeed that is read directly from the aircraft's airspeed indicator. The calibrated airspeed, or CAS, is indicated airspeed corrected for instrument and position errors. True airspeed, or TAS, is calibrated airspeed corrected for non-standard temperature and pressures. GS, or ground speed, is the actual speed over the ground, which accounts for wind effects. Let's talk about true airspeed computation. True airspeed is essential for accurate navigation, especially important when flying at higher altitudes. True airspeed increases with altitude because air density decreases. Now we can use the E6B to computate true airspeed.
Now we're going to talk about airspeed computation. Problem number 1, calculating true airspeed from indicated airspeed. You're flying at an indicated airspeed of 120 knots at 7,000 feet. The outside air temperature is 5 degrees Celsius. What is your true airspeed? So 7,000 feet on the pressure altitude scale and 5 degrees Celsius on the temperature scale. So I'm going to zoom in to here. So we have pressure altitudes in thousands of feet. So there's 0, 5,000, 10,000, and 5, 6, 7. So we need to align this 7 number with minus 5 degrees Celsius. So minus 50, plus 50. So 10, 20, 30, 40, 50 is going to be right there. So 10, so 5. So this line needs to line up now with 5, 6, and 7. So 7,000 feet pressure altitude. Okay. Now this one's a little counterintuitive, and I want you to kind of pay attention, because normally we would go from the outside in, meaning find 120 knots on the outer ring of the IAS of the indicated airspeed. What's actually saying is the outer of the ring here, okay? And then read the true airspeed on the inner scale, which is this one here. So 120, so this is going to be 100, 120, so 130, 131, 132 almost, we'll call it. So this one is the gotcha. This one is the little bit of a I wonder, understanding that we're gonna have to know which scales we're looking at. Okay. All right, next one, we're going to be finding density altitude. When you're flying at 5,000 feet pressure altitude with an outside air temperature of 20 degrees Celsius, what is the density altitude? Whoops, here we go. So first one, we're going to set the pressure altitude of 5,000 feet on the inner scale and align the outside air temperature of 20 degrees Celsius on the outer scale. So 5,000 feet, we're going to look at here, and 20 degrees. So positive 20. So 0, 10, 20, 30, 40, 50. So 0, 10, and 20, and 5,000 feet. Okay. Now, read the density altitude on the inner scale, which is approximately 6,600 feet. So let's verify. So 6,000, 6,500, 6,000. Oh man, I'm using a freaking bowling ball as a pointer here, but you can see that it's a little past 6,000 and it's past halfway. So 6,600 feet seems to be accurate there. Now, the next one is correcting true airspeed at higher altitudes. Your indicated airspeed is 150 knots, and you're flying at 10,000 feet with an outside air temperature of 10 degrees Celsius. What is your true airspeed? All right, so set 10,000 feet on the pressure altitude scale. So the pressure altitude scale is going to be 10,000, and align 10 degrees Celsius. So 10,000 is here. And oops, see what I did? It's minus 10, and we want plus 10. So let's go over here. So there's 0, and there's 10. So 10,000 feet, 10 plus 10 degrees Celsius. Find 150 knots indicated airspeed on the outer scale, and then read the inner scale at 174. So it's converse to what we need. So 150 knots indicated airspeed, and then we slide to this outer scale, which is 171, 2, 3, 4. 174 and a half, or 174 rounded. Again, this calculator, unfortunately, is not the most accurate online, but we're doing the best job we can. But let's move on. The next one, True airspeed calculations at different temperatures. You're flying at 8,000 feet with an indicated airspeed of 130 knots. The outside air temperature is minus 10 degrees. What is your true airspeed? So set 8,000 feet on the pressure altitude scale and align it with the minus 10 degrees Celsius on the temperature scale. So we're going to zoom in. We're going to find first 8,000 feet. So we know the 10 is here, the 5 is here. So 6, 7, 8. So 8 is right here. Now we need minus 10 degrees Celsius. So that's that first line here. And there we go. Now they're mostly lined up, kind of. So let's see, 5, 6, 7, 8, and then minus 10. So we're good. All right. So now we find 130 knots on the outer scale of the ring. And then the outermost scale is going to be about 144. So 5, 6, 7, 8. Yeah, it's not the most accurate answer here. I would have gone 144, but like I'm splitting hairs at that point. Like 145, 144. Last problem: indicated airspeed to true airspeed. A plane flies at 6,000 feet with an indicated airspeed of 140 knots. The outside air temperature is positive 5 degrees Celsius. What is the true airspeed? 6,000 feet, pressure altitude 5 degrees Celsius. So again, we're going to zoom in here. There's 6,000 feet plus 5 is going to be on which side of the zero? So plus 5 and 6,000 feet plus 5 degrees. Now 140 on this scale. And now we're looking at 150. 54, 56, 58, 160. So 153, honestly. 100. Yeah, I don't like that answer, but it's close enough. It'll get you right there. Again, I don't think, honestly, this E6B flight computer is 100% accurate. I think it is pretty damn good. But that's all we have for the airspeed computations.
If you love the overly technical lessons and the dry humor here on YouTube, you'll absolutely love my online helicopter ground school. I'll walk you through everything you need to know to become a helicopter pilot, minus the sarcasm. No, actually not. Yeah, there will be sarcasm. Head over to 3gheliprep.com and get started today.